Okay guys, let's take a look at our lesson for today. We're going to be looking at area under the curve. This is a pretty important topic in calculus, so I want to talk, kind of describe it just a little bit. It's one of our basic problems in calculus is to find the area under the curve. It's the area between the curve and the x-axis, between any two values of x. So here's an example. Say this was 1 and that's 5. So the calculator, this calculator is actually calculating this area, and you've seen that before. We've worked on that before with the calculator, where it will calculate the area under the curve for you. What we're going to be doing today is working on estimation techniques. The estimation techniques are pretty important. They're called Riemann Sums. I probably don't have that word written here anywhere, but that's what these little rectangles are called, Riemann Sums. And we're going to use them to estimate the area under the curve. We're going to use several rectangles. It will typically tell you how many to use. And there'd be different types of rectangles. So you could be using rectangles where you use the right corner of the rectangle to calculate your area. This would be in this example right here. Notice how the right top corner of each of the little rectangles is touching the actual function, the line or curve, we'll say. This is an example of right triangle or right rectangles. We could use left corners, and this is a picture of left corners where the left corner of each of the rectangles is touching the curve. The third type of rectangles we could use, they're called midpoints. And so what we would do, say we had a curve like that, we would go and the midpoint would be touching. So right here, the midpoint would be touching our function value right there. Okay, so that is called midpoints. So, and it'll also tell you which one to use, whether it's a right corner or a midpoint. So what we're going to do in the lesson is we're going to practice with the left and the right rectangles, and we're going to find the area of each one to get our approximation. So let's answer these questions before we go to our example. When would we get an underestimate? At what point would we have less area than we should? Well, if you look at this picture right here, you'll see that the rectangles don't really fill the space very well. There's some empty space left out here. I'll just kind of highlight it. That is part of the area, and this technique using right rectangles on a decreasing function, they're not giving us a pretty good estimate. They're actually giving us an underestimate. So that is one situation, and I'll write that down. So if we're using the right rectangles on a decreasing function, we get an underestimate. When do we get an overestimate? Well, let's look at this scenario. In this diagram, we see that the rectangles are exceeding, they're going above the function. And so we would, on this one, we would use a left, when we use a left rectangle on a decreasing function, we get an overestimate. So what about the reverse? When would we get an overestimate on a right rectangle? Well, if let's look at this right rectangle. Look at how we're on an increasing function. See that little part right there? When a function is increasing and we use right rectangles, we get an overestimate. So the right rectangles on an increasing function give us an overestimate. Now, you don't really have to memorize this. You can just draw the rectangles and figure it out. I'm just telling you the scenarios. Pretty important to know. And likewise, when would we get an underestimate when we're using left rectangles? Let's look at this. See, here's left rectangles, and there's that little space right there. On an increasing function using a left rectangle, I have extra space. So we get an underestimate with left rectangles on an increasing function. And that's going to hold true on all of them. Okay, so that's when we get over and under estimates. But again, if this is really too confusing to try to memorize, all you have to do is draw the picture and the rectangles, and you'll be able to tell whether it's an over or under estimate. All right, great. Let's go to our next, our examples. Okay. So on this first one, actually this is in two parts. We're going to do right endpoints and left endpoints. So, all right. Our function right here is f of x equals 1 over x. And it's already graphed for us. We want to go from 1 to 5 using an n of 4. N of 4 means how many rectangles you're going to be drawing. That's what that means, an n of 4. So I'm going to go from 1 to 5. And I'm going to do an n of 4 on both of them, from 1 to 5. On the first one, I'm going to do right endpoints. And on the second one, I'm going to do left endpoints. Alright, so let's think about what that means. So if I go over here, I can see I'm going to have 4 little rectangles right here. I want the right endpoint to be on the actual curve. And so, be this one. It's on the curve. That's my right endpoint. My right endpoint. Right, those are my little rectangles, and we just really use geometry. We're going to multiply 1, the width, so let's work on this rectangle first, times the height. The height is f of 2. That's what the function value at 2, plus 1 times, this height is f of 3, plus 1 times, this height would be f of 4, and the last height, the width is 1, and the height is f of 5. So to get those values, I go to the function. So f of 2, I plug a 2 in here, and I get 1/2, plus f of 3, I plug a 3 in, I get 1/3, plus plug a 4 in, 1/4, plug a 5 in, 1/5. And that gives me 77 over 60. Now this function is strictly decreasing. Strictly decreasing. Is it going to provide an under or over estimate? And if you've drawn your rectangles correctly, you should be able to tell pretty easily that this is going to be an underestimate. All right. So let's take a look at our left endpoints, and let's work with those. So for these rectangles, again, I need 4. It's telling me that I need 4 rectangles, and I'm going from 1 to 5. But this time I'm going to put the left corner of the rectangle on the curve. So the left corner goes on the curve. The left corner, and left corner. Kind of hard to tell in the really small parts. Alright, so we're going to calculate that. Now let's do a little bit of a shortcut. Notice how all of their widths are 1. Okay, that's not always going to be that way. This is a very nice, easy one. All the widths are 1, so I'm going to pull the 1 outside. That's my width. We find the area of a rectangle, length times width, so that's my width. And all I'm going to be worrying about is each of the function values, each of the heights. So this height is f of 1, this height is f of 2, this height is f of 3, and this height is f of 4. And so getting those function values, 1 times f of 1, I put a 1 up here, I get a 1, f of 2, and 3 and 4, and that gives me 25/12. And we would be asked, this is strictly decreasing function, is this an under or over estimate? And hopefully we can tell if our drawing is pretty good without memorizing that stuff I was telling you earlier, that it's an overestimate. We have extra parts of the rectangles there. So this is an overestimate. Now some students find, this is called Riemann Sums in calculus, some students find Riemann Sums pretty challenging, and some students are like, that is the easiest thing in the world, I just find the area of all the rectangles and add them up. So whichever camp that you're in, hopefully this helps describe these two techniques using right corners and left corners. All right.